Alright, children, this is 5.4, tangent. Okay, I thought I had this fixed, but it's kind of annoying me a little bit, so sorry. So I'm trying to keep these videos short. You know it's not working, so I'm pre-writing some stuff that you don't necessarily need in your notes. It's background information. Um, and then I'll write the examples as I go. Alright, so here we have a tangent function, and tangent is equal to sine over cosine. So since tangent has a denominator, it will have vertical asymptotes. Okay, remember denominators, x in denominator means vertical asymptotes. So that's when the cosine of x equals 0. So when is your denominator equal 0? That means which pi, guys, is cosine 0 at? Well, that's at the top of the unit circle and the bottom of the unit circle. Okay, top and bottom of the unit circle. So this is where cosine is always 0. So that is going to make vertical asymptotes. Okay, so all of those guys, and as you walk around the circle continuously, you hit all of those repeated spots. Okay, so we have vertical asymptotes for our tangent graphs. Here's a tangent graph, and remember, just like sine and cosine go on forever, so do your tangent graphs. They go on forever and ever and ever. However, I'm only going to always ask you for one cycle, just like with sine and cosine. So here is one cycle of a tangent graph. Okay, we're going to do that cycle. Alright, so our vertical asymptotes, where does tangent have bad numbers at? That's at pi over 2. So when you plug in pi over 2 into tangent, it's bad. When you plug in negative pi over 2 into tangent, it is bad. So there's where our vertical asymptote's at. It's when your input gives you a 0 in the denominator. Okay, so vertical asymptotes, where does the denominator equal 0? In those two spots. Okay, alright, so we have infinitely many asymptotes if we keep walking around the circle. But I only need one cycle. Okay, so this is one cycle here. Alright, now let's talk about this period of tangent. So for sine and cosine, the period is 2 pi. That's the original period for sine and cosine. You walk around the circle once and you get all the points. Well, for tangent, you only need to go to quadrant 1 and your signs are positive and positive. If you're in quadrant 3, your signs are also positive. Like if tangent is, so it's negative and negative. But when you do tangent, tangent equals positive. Because you have a negative over a negative, which equals a positive. So these are going to be the same outputs as this quadrant. So you don't need to count this quadrant. So we only need quadrant 1 for right now. And then down here, we're going to use quadrant 4, because this is positive and negative. So your tangent will equal a negative over a positive, which will give you a negative. Okay. This tangent is positive over a positive, which will give you positive. So you don't need to count 2. So we're only, to get all the famous spots in the unit circle, you only need to count these two quadrants. Because this guy is a negative comma positive, and tangent will equal a negative here. I've already counted a negative guy. So these two quadrants will give you all the outputs for your tangent function. I don't need to count these, that's just counting them double. So you only need half the circle to get all your outputs. Half the circle, the period is 2 pi. Okay? So your period, so if you go around the circle half, or if you count half of a circle, that is pi. If you want to see the math to that, so the width of this graph, okay, the width of this guy, like how wide is your graph? So for sine and cosine, our width is 2 pi. Our period is 2 pi. How wide is this graph? Well, you do the highest number minus the lowest number. Pi minus negative pi over 2. Sorry. That equals pi. So that's the width of your graph. That's your period. For sine and cosine, you have to go around the whole circle one time, so 2 pi, to get all of the outputs. For tangent, you only need half of the circle to get all of the outputs. So your period is only pi for tangent. Okay. So, here's all the information. And you have no amp because of your asymptotes. Okay. So your domain is, you're allowed to plug anything you want into the tangent function except for those pi over 2 guys. Okay. The range is all real numbers. Okay, there's no amp, there's no highest and lowest point because you have these asymptotes. So the range is all the numbers you can get out. Okay, they go, get all of them. For sine and cosine, you know your range is 1 and -1. Can't go higher than 1, can't go lower than -1. If your period is pi, okay, that's your original period, and your amp, you don't have none. Okay, so if you get anything like in front of a tangent function, you just ignore that. You don't have to worry about it. There's no amp. Okay, so just ignore. So the nice thing is we don't have to worry about amp for your tangent function. We do have to worry about asymptotes now. Okay. Alright, then I'm going to show you how to get those asymptotes as things change. Alright, so let's graph some tangent functions. So, graph g of x equals 2 tangent of 3x. We're going to graph that guy. Again, ignore the 2. There's no amp. Okay? You don't have to worry about it. But we do have to factor out this 3 to figure out our new period. So 2 tangent of 3 times x. Okay? So our amp, don't worry about it, but our new period equals the old period over b, which equals pi. The original period of pi, or of tangent is period. I can't even talk. The original period of tangent is pi. So old or original over the coefficient, which is 3. So our new period is pi over 3. Okay. Alright. We have no shifts, so then you would do shift, flip, flip, shift. Okay. Left, right, shift. No. Up, down, or left, right, flip. No. Up, down, flip. No. Up, down, shift. No. Sweet. Okay. So, I'm going to start with my original. Just to remember, my original, my basic tangent, we split it in half. Half of it on the positive side, half of it on the negative side. X equals negative pi over 2, x equals pi over 2, okay. And it goes through the origin, and it's not flat. My first picture kind of made it look flat, but it's not like a cubic, it's not flat. So there's my original, okay. That's what you would have to show on your basic. So again, we don't have amps. Now we do have a new period though. Okay. You still, half on the left, half on the right, x equals, x equals. Now, so this period was pi, okay? And our asymptotes were at negative pi and pi over 2. So it's like, well, Sam, how do you get your asymptotes? Well, when I say the period is pi, that means how wide it is. It's the width, okay? That's the width of it. So it's pi. That's pi units wide. So if half of my graph is on the left and half of my graph is on the right, if I take my period and divide it by 2, that'll give you your asymptotes. So I want to cut that pi in half. Half on the left, half on the right. So my period is pi divided by 2. There's my asymptotes. There we go. Alright, so let's do it for this one. My period equals pi over 3. That's my new period. So my asymptotes, cut it in half. Pi over 3 divided by 2. That's pi over 3 times 1/2. Pi over 6. Oh yeah, half of a third is a sixth. So it makes sense that this is negative pi over 6, positive pi over 6. So we squished it. We took this graph and then we put it in between here. That's what we did. We squished it. We made it more narrow. So, draw your graph. Again, the 2 doesn't matter. There's no amp. Like that, you ignore that. So there's your tangent graph. Yes, we're going to do shifts and flips and all that stuff, and we got to watch our asymptotes, but there is one with a new period. And that's how you find your asymptotes. Divide your period in half, because you're cutting your graph in half. Alright, let's do another one. Here's B. Now I'm going to get fancy. F of x equals negative tangent of 3x minus pi over 3. Oh, I lied. I lied. I'm going to change that. I'm going to do minus pi over 6. I'm going to do pi over 2. Sorry, I had to think about that. Sorry. Alright, so we need to rewrite this guy. Negative tangent, factor out a 3 of x minus pi over. Again, when you factor out, it's dividing by the number you're factoring out. So you're dividing by 3, which is really multiplying by a third. So pi over 6. Alright, so now we factored it out. We have our correct shift. Now we can get our information. Again, don't worry about the amp. So our period, our new period, is the original, which is pi, over the coefficient. So our period is pi over 3. Alright, so similar to the last one. Okay, cool. So it won't be that bad. So I'm going to do my graph with my new period and my asymptotes. So period asymptotes is pi over 3 divided by 2, which is pi over 6. Just like the last example. So x equals negative pi over 6 and positive pi over 6. And then you graph your tangent graph. Now we have to do our shift, flip, flip, shift, which I kind of got ahead of myself and didn't write it down. Okay. So shift left, right. Yes, we're going to go right pi over 6. Flip up left, right. No. Flip up, down. Yes. Because there's a negative out here. And shift up, down. Nope. Okay. Alright, so now we got to go right 3. Right, pi over 6. Sorry. I need more coffee, guys. Alright. Let me get some work down. So here are the points that you're going to have to shift. You're going to have to show. So here's my A, that's my first guy. B, that's center. And then C. Okay. Technically, you can find these marks right here, these famous guys in between. I'm not worried about them. I'm only worried about those 3 for tangent. So there you go. You have less critical points for tangent. I don't care about the other critical points. You would just half of that. It would be pi over 12s. But I don't care about it. Those are the 3 I want to see for tangent. That's it. Alright. So A is negative pi over 6, and we're going to the right, so plus pi over 6. B is 0 plus pi over 6. And C is pi over 6 plus pi over 6. Alright, negative pi over 6 plus pi over 6 is 0. 0 plus pi over 6 is pi over 6. Pi over 6 plus pi over 6 is 2 pi over 6. If you want to simplify it to pi over 3, I don't care. So now that everybody should be listening to this video, I don't care if you simplify your famous spots. They're not going to mark it wrong on the final. So I won't mark it wrong on your homework or test or quiz. Alright, so here we go. Let's shift this guy. So this guy is going to get shifted to the right. So A is going to become 0. So this new asymptote is going to shift over and become 0. The middle point is going to shift over and become pi over 6. and this side of the graph is going to shift over and become pi over 3. So that's what's going on. So at x equals 0, you're going to label your asymptotes. So that's A. B is the middle, which is pi over 6. And then C is the other asymptote, which is pi over 3, or 2 pi over 6. I don't care how you label it. It's up to you. So then you draw your graph. There it is. There's the middle. Okay. So that was your left-right shift. So right pi over 6. Alright, and last but not least, we have a up-down flip. So this is like flipping your cubic graph. Okay. Your up-down flip does not affect your x values, so these guys stay the same. So it doesn't change this x value either. But it flips it up-down. So this up part is going to go down here, and this down part is going to go up there. So it's going to do this. So this guy went up, and this guy went down. So you got to label the 3 spots, your intercepts and that middle guy, and that's it. That's all I want for tangent. Alright, I wish I could ask questions, comments, concerns, but I can't. So let's do another one. Okay. Give you some time to write that down if you're taking notes, like you should be when you're watching these videos. Again, make notes in your notes and questions you have for office hours. Kirsten wrote down little post-it notes to remind herself what she wanted to ask. Whatever helps you when you come into office hours. Alright, here's C. If I find the example, I'll give it to you. There it is. Tangent, f of x equals tangent of negative 3x plus pi. I'm going to change it. I'm going to do 4. Plus pi over 2 plus 1. There. Alright, here we go. We need to factor this out first, and again you're only factoring out the positive 4. Leave the negative in there so we can see our flip, so it doesn't change the sign, and that's pi over 2 divided by 4, which is pi over 2 times 1/4 equals pi over 8. Okay, so 8 plus 1. Alright, here we go. So, I have my new period. Remember, amp doesn't matter. You have tangent, which is the original pi, over the coefficient, which is 4. So that's your new period, pi over 4. Okay? And if you want right away, you can write down your asymptotes. That's pi over 4 divided by 2. Seriously? It's the same as my shift? Come on. Is it really? Times 1/2, yeah. I didn't think that was going to happen. But okay, your asymptotes are the same as your shift. That is nice. Does that happen in the last example? Right pi over 6? Yeah. Does that always happen? Sorry guys, clearly I'm just thinking out loud in my head. Out loud of what's going on in my head. Alright, let's keep it moving. So, plus or minus. Those are your asymptotes. Shift, flip, flip, shift. So we're going to go left, because it's plus 8, left pi over 8, plus pi over 8. Left, right, shift, or flip, sorry, yes. Up, down, flip, no. These F's are ugly. And then shift, up, down, yes. Up 1. Alright, here we go. So I'm going to draw it with my new period. That's x equals negative pi over 8. And x equals pi over something. Pi over 8. Sorry, my brain's not working. Sorry, guys. Oh, they're my asymptotes. My graph goes through the origin. And now we have to shift left, right. Alright, here we go. A is negative pi over 8. 0. B is 0. And C is positive pi over 8. And then we're going to go left. Okay, so left is minus pi over 8, minus pi over 8, minus pi over 8. Alright, so negative pi over 8, but that's negative 2 pi over 8, or pi over 4, negative pi over 4, that's up to you how you want to write it. That's negative pi over 8, and that's 0. Alright, so let's shift it. So left pi over 8. So we're going to be on the negative side, and just 0. So my graph is over here. X equals 0. X equals negative pi over 4, or 2 pi, negative 2 pi over 8. It's up to you. Okay. There's my A, my C, and my B is negative pi over 8. There's my shift. There's my asymptotes. Okay. So it's left pi over 8. Alright, now we're going to flip it left to right. So we're going to take this whole graph and flip it over the y-axis. So we're going to do flip it over to the right. So two different colors for you. So we're going to flip left, right. That means flipping left, right, it affects our x values. So x values flip. Okay. So we go to x is positive pi over 4, x is positive pi over 8, and x is 0, 0. Okay, so we still have x is 0 as our asymptote. X equals 0. X equals positive pi over 4 now for our other asymptote. And then in our middle guy is x is now positive pi over 8. And we flip this guy over. So this guy flips over this side, and this guy flips all the way over to that side. Like that. That's this. A little bit more. And that purple side is this. So that's your left-right flip. Your new asymptotes. Alright, and last but not least, we have an upshift. Okay, so we're going to take this and shift up. So that affects your y values. So x, y values. So it doesn't affect your asymptotes. Your asymptotes are x values, so it doesn't affect those. But it will affect this y value. So we have, right now we're at pi over 8 comma 0 for our intercept. So we're going to add 1, so it's going to be pi over 8 comma 1. So we have still this guy, x equals 0. Still this guy, x equals pi over 4. still in the middle at pi over 8, but now we're going to go up 1. So this is 1. So now the center point is going to be there. Oh, whoops, on the other side. So let me color coordinate for you guys. So the purple moved up. Okay. That's what happened. And that's all I need. I just need the asymptotes and your other critical point. There's your graph. Again, I wish I could say any questions or comments. There's tangent. So you do more flips, whatever, where I am, but that's all the work that I need for tangent stuff. Okay? Alright, I think this is one of the shorter videos.